Studies of Interference in Serial Verbal Reactions. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Nikki Sullivan, Pasadena, California. Studies of Interference in Serial Verbal Reactions by J. Ridley Stroop. George Peabody College. First published in Journal of Experimental Psychology, 643 through 662. Introduction. Interference or inhibition, this term seems to have been used almost indiscriminately, has been given a large place in experimental literature. The investigation was begun by the physiologists prior to 1890, Bowditch and Warren, J.W., 1890, and has been continued into the present principally by psychologists, Lester, 1932. Of the numerous studies that have been published during this period, only a limited number of the most relevant reports demand our attention here. Munsterberg, 1892, studied the inhibiting effects of changes in common daily habits such as opening the door of his room, dipping his pen in ink, and taking his watch out of his pocket. He concluded that a given association can function automatically, even though some effect of a previous contrary association remains. Mueller and Schumann, 1894, discovered that more time was necessary to relearn a series of nonsense syllables if the stimulus syllables had been associated with other syllables in the meantime. From their results, they deduced the law of associative inhibition, which is quoted by Klein, 1921, page 270, as follows. If A is already connected with B, then it is difficult to connect it with K. B gets in the way. Nonsense syllables were also used by Shepard and Vogelsanger, 1913, in a series of experiments on association and inhibition. Only 3 subjects were used in any experiment, and the changes introduced to produce the inhibition were so great in many cases as to present novel situations. This latter fact was shown by introspections. The results showed an increase in time for the response which corresponded roughly to the increase in the complexity of the situation. The only conclusion was stated thus. We have found that in acquiring associations there is involved an inhibitory process which is not a mere result of the divided paths, but has some deeper basis yet unknown. Page 311. Klein, 1921, used meaningful material, states and capitals, counties and county seats, and books and authors, in a study of interference effects of associations. He found that if the first associative bond had a recall power of 10% or less, it facilitated the second association. If it had recall power of 15% to 40%, the inhibitory power was small. If it had a recall power of 45% to 70%, the inhibiting strength approached a maximum. And if the recall power was 70% to 100%, the inhibition was of medium strength and in some cases might disappear or even facilitate the learning of a new association. In card sorting, Bergstrom, 1893 and 1894, Brown, 1914, Blair, 1902, and Koller, 1912, found that changing the arrangement of compartments into which cards were being sorted produced interference effects. Bergstrom, 1894, page 441, concluded that the interference effect of an association bears a constant relation to the practice effect, and is, in fact, equivalent to it. Both Blair and Koller found that the interference of the opposing habits disappeared if the habits were practiced alternately. Koller, 1912, in the paper already referred to, reported 2 other experiments. In one experiment, the subjects associated each of a series of numbers with striking a particular key on the typewriter with a particular finger. Then, the keys were changed so that 4 of the numbers had to be written with fingers other than those formerly used to write them. In the other experiment, the subjects were trained to react with the right hand to red and with the left hand to blue. Then the stimuli were interchanged. In the former experiment, an interference was found which decreased rapidly with practice, In the latter experiment, the interference was overbalanced by the practiced effect. Hunter and Yarbrough, 1917, Pierce, 1917, and Hunter, 1922, in 3 closely related studies of habit interference in the white rat in a T-shaped discrimination box, found that a previous habit interfered with the formation of an opposite habit. Several studies have been published which are not primarily studies of interference, but which employed materials that were similar in nature to those employed in this research, and which are concerned with why it takes more time to name colors than to read color names. Several of these studies have been reviewed by Telford, 1930, and Ligon, 1932. Only the vital part of these studies will be mentioned here. The difference in time for naming colors and reading color names has been variously explained. Cattell, 1886, and Lund, 1927, have attributed the difference to practice. Woodworth and Wells, 1911, page 52, have suggested that the real mechanism here may very well be the mutual interference of the 5 names, all of which, from immediately preceding use, are on the tip of the tongue. All are equally ready and likely to get in one another's way. Brown, 1915, page 51, concluded that the difference in speed between color naming and word reading does not depend upon practice, but that, page 34, the association process in naming simple objects like colors is radically different from the association process in reading printed words. Garrett and Lemon, 1924, page 438, have accounted for their findings in these words. Hence it seems reasonable to say that interferences which arise in naming colors are due not so much to an equal readiness of the color names as to an equal readiness of the color recognitive process. Another factor present in interference is very probably the present strength of the associations between colors and their names, already determined by past use. Peterson, 1918 and 1925, has attributed the difference to the fact that one particular response habit has become associated with each word, while in the case of colors themselves, a variety of response tendencies have developed. 1925, page 281. As pointed out by Telford, 1930, the results published by Peterson, 1925, page 281, and also published by Lund, 1927, page 425, confirmed Peterson's interpretation. Ligon, 1932, has published results of a genetic study of naming colors and reading color names, in which he used 638 subjects from school grades 1 to 9 inclusive. In the light of his results, he found all former explanations untenable. He included no examination of or reference to Peterson's data and interpretation, and proceeded to set up a new hypothesis based on a 3-factor theory, a common factor which he never definitely describes, and special factors of word reading and color naming. He points out that the common factor is learned, but the special factors are organic. He promises further evidence from studies now in progress. The present problem grew out of experimental work in color naming and word reading conducted in Jessup Psychological Laboratory at George Peabody College for teachers. The time for reading names of colors has been compared with the time for naming colors themselves. This suggests a comparison of the interfering effect of color stimuli upon reading names of colors, the 2 types of stimuli being presented simultaneously, with the interfering effect of word stimuli upon naming colors themselves. In other words, if the word red is printed in blue ink, how would the interference of the ink color blue upon reading the printed word red compare with the interference of the printed word red upon calling the name of the ink color blue? The increase in time for reacting to words caused by the presence of conflicting color stimuli is taken as the measure of the interference of color stimuli upon reading words. The increase in the time for reacting to colors caused by the presence of conflicting word stimuli is taken as the measure of the interference of word stimuli upon naming colors. A second problem grew out of the results of the first. The problem was, what effect would practice in reacting to the color stimuli in the presence of conflicting word stimuli have upon the reaction times in the two situations described in the first problem? Experiment 1. The effect of interfering color stimuli upon reading names of colors serially. Materials. When this experiment was contemplated, the first task was to arrange suitable tests. The colors used on the Woodworth-Wells color sheet were considered, but two changes were deemed advisable. As the word test to be used in comparison with the color test was to be printed in black, it seemed well to substitute another color for black as an interfering stimulus. Also, because of the difficulty of printing words in yellow that would approximate the stimulus intensity of the other colors used, yellow was discarded. After consulting with Dr. Peterson, black and yellow were replaced by brown and purple. Hence, the colors used were red, blue, green, brown, and purple. The colors were arranged so as to avoid any regularity of occurrence, and so that each color would appear twice in each column and in each row, and that no color would immediately succeed itself in either column or row. The words were also arranged so that the name of each color would appear twice in each line. No word was printed in the color it named, but an equal number of times in each of the other four colors, i.e., the word red was printed in blue, green, brown, and purple inks. The word blue was printed in red, green, brown, and purple inks. The word blue was printed in red, green, brown, and purple inks, etc. No word immediately succeeded itself in either column or row. The test was printed from 14-point Franklin lowercase type. The word arrangement was duplicated in black print from the same type. Each test was also printed in the reverse order, which provided a second form. The tests will be known as reading color names where the color of the print and the word are different, RCN-D, and reading color names printed in black, RCN-B. Subjects and procedure. 70 college undergraduates, 14 males and 56 females, were used as subjects. Every subject read 2 whole sheets, the 2 forms, of each test at one sitting. 1/2 of the subjects of each sex, selected at random, read the tests in the order RCN-B, Form 1, RCN-D, Form 2, RCN-D, Form 1, and RCN-B, Form 2, while the other half reversed the order, thus equating for practice and fatigue on each test and form. All subjects were seated so as to have good daylight illumination from the left side only. All subjects were in the experimental room a few minutes before beginning work to allow the eyes to adjust to light conditions. The subjects were volunteers and apparently motivation was good. A 10-word sample was read before the first reading of each test. The instructions were to read as quickly as possible and to leave no errors uncorrected. When an error was left, the subject's attention was called to that fact as soon as the sheet was finished. On the signal, "Ready, go," the sheet which the subject held face down was turned by the subject and read aloud. The words were followed on another sheet, in black print, by the experimenter, and the time was taken with a stopwatch to 1/5 of a second. Contrary to instructions, 14 subjects left a total of 24 errors uncorrected on the RCN-D test. 4 was the maximum for any subject, and 4 other subjects left 1 error each on the RCN-B test. As each subject made 200 reactions on each test, this small number of errors was considered negligible. The work was done under good daylight illumination. Results. Table 1 gives the means, standard deviations, differences, probable error of the difference, and the reliability of the difference for the whole group for each sex. Observation of the bottom line on the table shows that it took an average of 2.3 seconds longer to read 100 color names printed in colors different from that named by the word than to read the same names printed in black. This difference is not reliable, which is in agreement with Peterson's predictions made when the test was first proposed. The means for the sex groups shows no particular difference. An examination of the means and standard deviations for the two tests shows that the interference factor caused a slight increase in the variability for the whole group and for the female group, but a slight decrease for the male group. Table 2 presents the same data arranged on the basis of college classification. Only college years 1 and 2 contain a sufficient number of cases for comparative purposes. They show no differences that approach reliability. Experiment 2. The effect of interfering word stimuli upon naming colors serially. Materials. For this experiment, the colors of the words in the RCND task, described in Experiment 1, were printed in the same order, but in the form of solid squares from 24-point type instead of words. This sort of problem will be referred to as the naming color test in C. The RCND test was employed also, but in a very different manner from that in Experiment 1. In this experiment, the colors of the print on the series of names were to be called in succession, ignoring the colors named by the words, e.g., where the word red was printed in blue, it was to be called blue. Where it was to be printed in green, it was to be called green. Where the word brown was printed in red, it was to be called red, etc. Thus the color of the print was to be the controlling stimuli and not the name of the color spelled by the word. This is to be known as the naming color or word test, where the color of the print and the word are different, in CWD. See Appendix B. Subjects and procedure. 100 students, 88 college undergraduates, 29 males and 59 females, and 12 graduate students, all females, served as subjects. Every subject read 2 whole sheets, the 2 forms, of each test at one sitting. Half of the subjects read in the order in C, in CWD, in CWD, in C, and the other half in the order in CWD, in C, in C, in CWD, thus equating for practice and fatigue on the 2 tests. All subjects were seated in their individual tests near the window so as to have good daylight illumination from the left side. Each subject seemed to make a real effort. A 10-word sample of each test was read before reading the test the first time. The instructions were to name the colors as they appeared in regular reading lines as quickly as possible and to correct all errors. The methods of starting, checking errors, and timing were the same as those used in Experiment 1. The errors were recorded, and for each error not corrected, twice the average time per word for the reading of the sheet on which the error was made was added to the time taken by the stopwatch. This plan of correction was arbitrary, but seemed to be justified by the situation. There were 2 kinds of failures to be accounted for. First, the failure to see the error, and second, the failure to correct it. Each phase of the situation gave the subject a time advantage which deserved taking note of. Since no accurate objective measure was obtained and the number of errors was small, the arbitrary plan was adopted. 59% of the group left an average of 2.6 errors uncorrected on the NCWD test, 200 reactions, and 32% of the group left an average of 1.2 errors uncorrected on the NC test, 200 reactions. The correction changed the mean of the NCWD test from 108.7 to 110.3, and the mean of the NC test from 63.0 to 63.3. Results. The means of the times for the NC and the NCWD tests for the whole group and for each sex are presented in Table 3 along with the difference, the probable error of the difference, the reliability of the difference, and the difference divided by the mean time for the naming color test. The comparison of the results for the whole group on the NC and the NCWD test, given the bottom line of the table, indicates the strength of the interference of the habit of calling words upon the activity of naming colors. The mean time for 100 responses is increased from 63.3 seconds to 110.3 seconds, or an increase of 74%. The medians on the two tests are 61.9 and 110.4 seconds, respectively. The standard deviation is increased in approximately the same ratio, from 10.8 to 18.8. The coefficient of variability remains the same to the third decimal place, S/M equals 0.171. The difference between means may be better evaluated when expressed in terms of the variability of the group. The difference of 47 seconds is 2.5 standard deviation units in terms of the NCWD test, or 4.35 standard deviation units on the NC test. The former shows that 99% of the group on the NCWD test was above the mean on the NC test, took more time, and the latter shows that the group as scored on the NC test was well below the mean on the NCWD test. These results are shown graphically in Figure 1, where histograms and normal curves obtained by the Gaussian formula of the two sets of data are superimposed. The small area in which the curves overlap and a 74% increase in the mean time for naming colors caused by the presence of word stimuli show the marked interference effect of the habitual response of calling words. The means for the sex groups on the NCWD test show a difference of 3.6 seconds, which is only 1.16 times its probable error. But the means on the NC test have a difference of 8.2 seconds, which is 5.17 times its probable error. This reliable sex difference favoring the females in naming colors agrees with the findings of Woodworth-Wells 1911, Brown 1915, Ligon 1932, etc. The same data are arranged according to college classification in Table 4. There is some indication of improvement of the speed factor for both tests as the college rank improves. The relative difference between the two tests, however, remains generally the same, except for fluctuations which are probably due to the variation in the number of cases. Experiment 3. The effects of practice upon interference. Materials. The tests used were the same in character as those described in Experiments 1 and 2. RCNB, RCND, NC, and NCWD, with some revision. The NC test was printed in swastikas instead of squares. Such a modification allowed white to appear in the figure with the color, as is the case when the color is presented in the printed word. This change also made it possible to print the NC test in shades which more nearly match those in the NCWD test. The order of colors was determined under one restriction other than those given in Section 2. Each line contained one color whose two appearances were separated by only one other color. This was done to equate as much as possible the difficulty of the different lines of the test so that any section of 5 lines would approximate the difficulty of any other section of 5 lines. 2 forms of the test were printed. In one, the order was the inverse of that in the other. Subjects and procedure. 32 undergraduates in the University of Arizona, 17 males and 15 females, who offered their services, were the subjects. At each day's sitting, 4 half-sheets of the same test were read, and the average time after correction was made for errors according to the plan outlined in Experiment 2 were recorded as the day's score. Only a few errors were left uncorrected. The largest correction made on the practice test changed the mean from 49.3 to 49.6. The plan of experimentation was as follows. On the first day, the RCNB test was used to acquaint the subjects with the experimental procedure and improve the reliability of the second day's test. The RCND test was given the second day and the 13th day to obtain a measure of the interference developed by practice on the NC and NCWD tests. The RCND test was given on the 14th day to get a measure of the effect of a day's practice upon the newly developed interference. The NC test was given on the 3rd and 12th days, just before and just after the real practice series, so that actual change in interference on the NCWD test might be known. The test schedule was followed in regular daily order with 2 exceptions. There were 2 days between test days 3 and 4, and also between test days 8 and 9, in which no work was done. These irregularities were occasioned by weekends. Each subject was assigned a regular time of day for his work throughout the experiment. All but 2 subjects followed the schedule with very little irregularity. These 2 were finally dropped from the group and their data rejected. All of these tests were given individually by the author. The subject was seated near a window so as to have good daylight illumination from the left side. There was no other source of light. Every subject was in the experimental room for a few minutes before beginning work to allow his eyes to adapt to the light conditions. To aid eye adaptation and to check for clearness of vision, each subject read several lines in a current magazine. Every subject was given Dr. Ishihara's tests for color vision. One subject was found to have some trouble with red-green color vision, and her results were discarded, though they differed from others of her sex only in the number of errors made and corrected. Results. The general results for the whole series of tests are shown in Table 5, which presents the means, standard deviations, and coefficients of variability for the whole group and for each sex separately, together with a measure of sex difference in terms of the probable error of the difference. Table 6, which is derived from Table 5, summarizes the practice effects upon the respective tests. The graphical representation of the results in the practice series gives the learning curve presented in Figure 2. The effect of practice on the NCW test upon itself. The data to be considered here are those given in the section of Table 5 under the caption, Days of Practice on the NCWD Test. They are also presented in summary in the left section of Table 6 and graphically in Figure 2. From all 3 presentations, it is evident that the time score is lowered considerably by practice. Reference to Table 6 shows a gain of 16.8 seconds, or 33.9% of the mean of the first day's practice. The practice curve is found to resemble very much the typical learning curve when constructed on time units. The coefficient of variability is increased from 0.14 plus or minus 0.012 to 0.19 plus or minus 0.015. This difference divided by its probable error gives 2.60, which indicates that it is not reliable. The probability of a real increase in variability, however, is 24 to 1. Hence, practice on the NCWD test serves to increase individual differences. An examination of the data of sex groups reveals a difference in speed on the NCWD test which favors the females. This is to be expected as there is a difference in favor of females in naming colors. Though the difference is not reliable in any one case, it exists throughout the practice series, indicating that the relative improvement is approximately the same for the 2 groups. This latter fact is also shown by the ratio of the difference between the halves of practice series to the first half. It is 0.185 for the males and 0.180 for the females. The effect of practice on the NCWD test upon the NC test. The middle section of Table 6 shows a gain on the NC test of 4.0 seconds, or 13.9% of the initial score. This is only 23.7% of the gain on the NCWD test, which means that less than 1/4 of the total gain on the NCWD test is due to increase in speed in naming colors. The improvement is greater for the males, which is accounted for by the fact that there is more difference between naming colors and reading names of colors for the males than for the females. The effects in the RCND test of practice on the NCWD and NC tests. The right section of Table 6 shows that the practice on the NCWD and NC tests resulted in heavy loss in speed on the RCND test. A comparison of the right and left sections of the table shows that the loss on RCND test, when measured in absolute units, is practically equal to the gain on the NCWD test. When measured in relative units, it is much greater. It is interesting to find that in 10 short practice periods, the relative values of opposing stimuli can be modified so greatly. There is little relation, however, between the gain in one case and the loss in the other. The correlation between gain and loss in absolute units is 0.262 plus or minus 0.11, while the correlation between percent of gain and percent of loss is 0.016 plus or minus 0.17, or 0. This is what one might expect. From a consideration of the results of the two applications of the RCND test given in the final tests of Table 5, it is evident that the newly developed interference disappears very rapidly with practice. From one day to the next, the mean decreases from 34.8 to 22.0 seconds. This indicates that renewing the effectiveness of old associations which are being opposed by newly formed ones is easier than strengthening new associations in opposition to old well-established ones. The variability of the group is increased by the increase in interference due to practice on the NCWD test. The coefficient of variability increases from 0.15 plus or minus 0.013 to 0.34 plus or minus 0.031, the difference divided by its probable error being 5.65. This is not surprising, as the degree of the interference varies widely from different subjects. Its degree is determined by the learning on the practice series, which is shown by the individual results to vary considerably. One day's practice on the RCND test reduced the variability from 0.34 plus or minus 0.031 to 0.25 plus or minus 0.022. The decrease in variability is 2.3 times its probable error. The data from this experiment present interesting findings on the effect of practice upon individual differences. The results, which have already been discussed separately, are presented for comparison in Table 7. These results show that practice increases individual differences where a stimulus to which the subjects have a habitual reaction pattern is interfering with reactions to a stimulus for which the subjects do not have a habitual reaction pattern, the word stimulus interfering with naming colors in CWD test, but decreases individual differences where a stimulus to which the subjects do not have a habitual reaction pattern is interfering with reactions to a stimulus in which the subjects have a habitual reaction pattern, the color stimulus interfering with reading words, RCND test. There are two other variables involved, however: initial variability and length of practice. Thus, in the NCWD test, the initial variability was less, the difficulty greater, and the practice greater than in the RCND test. These findings lend some support to Peterson's hypothesis. Subjects with normal heterogeneity would become more alike with practice on the simpler processes or activities, but more different on the more complex activities. Peterson and Barlow, 1928, page 228. A sex difference in naming colors has been found by all who have studied color naming and has been generally attributed to the greater facility of women in verbal reactions than of men. There is some indication in our data that this sex difference may be due to the difference in the accustomed reactions of the two sexes to colors as stimuli. In other words, responding to a color stimulus by naming the color may be more common with females than with males. This difference is probably built up through education. Education in color is much more intense for girls than for boys, as observing, naming, and discussing colors relative to dress is more common among girls than among boys. The practice in naming colors in the NCWD test decreased the difference between the sex groups on the NC test from a difference 5.38 times its probable error to a difference 2.99 times its probable error. This decrease in the difference due to practice favors the view that difference has been acquired and is therefore a product of training. Summary 1. Interference in serial verbal reactions has been studied by means of newly devised experimental materials. The source of the interference is in the materials themselves. The words red, blue, green, brown, and purple are used on the test sheet. No word is printed in the color it names, but an equal number of times in each of the other four colors, i.e., the word red is printed in blue, green, brown, and purple inks. The word blue is printed in red, green, brown, and purple inks, etc. Thus, each word presents the name of one color printed in ink of another color. Hence, a word stimulus and a color stimulus both are presented simultaneously. The words of the test are duplicated in black print, and the colors of the test are duplicated in squares or swastikas. The difference in the time for reading the words printed in colors and the same words printed in black is the measure of interference of color stimuli upon reading words. The difference in the time for naming the colors in which the words are printed and the same colors printed in squares or swastikas is the measure of the interference of conflicting word stimuli upon naming colors. 2. The interference of conflicting color stimuli upon the time for reading 100 words, each word naming a color unlike the ink color of its print, caused an increase of only 2.3 seconds, or 5.6% over the normal time for reading the same words printed in black. This increase is not reliable, but the interference of conflicting word stimuli upon the time for naming 100 colors, each color being the print of a word which names another color, caused an increase of 47 seconds, or 74.3% of the normal time for naming colors printed in squares. These tests provide a unique basis, the interference value, for comparing the effectiveness of the two types of associations. Since the presence of the color stimuli caused no reliable increase over the normal time for reading words, D over PE sub D equals 3.64, and the presence of word stimuli caused a considerable increase over the normal time for naming colors, 4.35 standard deviation units, the associations that have been formed between the word stimuli and the reading response are evidently more effective than those that have been formed between the color stimuli and the naming response. Since these associations are products of training, and since the difference in their strength corresponds roughly to the difference in training in reading words and naming colors, it seems reasonable to conclude that the difference in speed in reading names of colors and in naming colors may be satisfactorily accounted for by the difference in training in the two activities. The word stimulus has been associated with the specific response to read, while the color stimulus has been associated with various responses: to admire, to name, to reach for, to avoid, etc. 3. As a test of the permanency of the interference of conflicting word stimuli to naming colors, 8 days practice, 200 reactions per day, were given in naming colors of the print of words, each word naming a color unlike the ink color of its print. The effects of this practice were as follows. 1. It decreased the interference of conflicting word stimuli to naming colors, but did not eliminate it. 2. It produced a practice curve comparable to that obtained in many other learning experiments. 3. It increased the variability of the group. 4. It shortened the reaction time to colors presented in color squares. 5. It increased the interference of conflicting color stimuli upon reading words. 4. Practice was found either to increase or to decrease the variability of the group depending on the nature of the material used. 5. Some indication was found that sex difference in naming colors is due to the difference in the training of the two sexes. Manuscript received August 15, 1934. Footnotes. 1. The writer wishes to acknowledge the kind assistance received in the preparation of this thesis. He is indebted to Dr. Joseph Peterson for encouragement, helpful suggestions, and criticism of the manuscript, to Major H.W. Finker, a graduate student in psychology, for helpful suggestions relative to preparation of the manuscript, to Drs. J. Peterson, S.C. Garrison, M.R. Schnick, J.E. Castor, O.A. Simley, W.F. Smith, and to Miss M. Nicol for aid in securing subjects, to some 300 college students who served as subjects, to William Fitzgerald of the Peabody Press for substantial assistance in the printing of the test materials. 2. Discordis, 1914, and also Goodenough and Bryan, 1929, presented color and form simultaneously in studying their relative values as stimuli. 3. In Appendix A will be found a key to all symbols and abbreviations used in this paper. Appendix A, a key to symbols and abbreviations. NC, naming colors. NCWD, naming the colors of the print words where the color of the print and the word are different. RCNB, reading color names printed in black ink. RCND, reading color names where the color of the print and the word are different. D, difference. D over PE sub D, difference divided by the probable error of the difference. M and F, males and females. PE sub D, probable error of the difference. S, sigma or standard deviation. S over M, standard deviation divided by the mean. End of Studies of Interference in Serial Verbal Reactions. Recording by Nikki Sullivan, Pasadena, California.